In this video, we're going to be completing complex fraction example number 5. Recall that a complex fraction is a fraction that contains a fraction. Example 5. 4 1/3 divided by 7 7/8. Step 1 says convert both the numerator and denominator to fractions. In this problem, I need to convert the numerator and denominator to improper fractions since the original numbers are mixed numbers. They're written as mixed numbers. I'm going to start by converting the mixed number in the numerator to an improper fraction. To do that, I need to multiply 4 times 3, and I get 12. Then I add the numerator to 12 to get 13, which is the new numerator of this improper fraction. The denominator remains a 3. Then I'm going to exaggerate this fraction bar in between my two fractions. And then I'm going to convert 7 7/8 to an improper fraction. 7 times 8 gives me 56. And then I add the numerator, which is 7. And that gives me 63. The denominator stays an 8. And then I'm ready now for step 2. Step 2, change out the fraction bar for the other division symbol. So I record the division symbol. 13/3 divided by 63/8. Since you say 13/3 first, you record 13/3 first on the left. Then you record the denominator, 63/8. And now I'm ready for step 3. Step 3. Use the keep change reciprocal method to change division to multiplication and then multiply. I keep the 13/3. We don't change that. We change the division to multiplication, and then we record the reciprocal of 63/8. The reciprocal of 63/8 is 8/63. Then we multiply across like we normally would with a fraction. 13 we multiply by 8. Well, let me try that again. That looks a little bit better. 3 times 8 is 24. Carry the 2. 1 times 8 is 8, plus 2 is 10. 13 times 8 gives me 104. Then I need to multiply 3 by 63. Three times 3 gives me 9, and 6 times 3 gives me 18. So we have 189. So now I need to go through my divisibility rules and see if there's anything that I can divide both 104 and 189 by. So I know that they can't both be divided by 2 because in the ones place for 189 we have an odd number. So you can't divide them both by 2. 4 plus 0 plus 1 is 5, and 5 is not a multiple of 3, so 104 is not divisible by 3. If 104 is not divisible by 3, then I don't even need to check this one, because they both have to be divisible by 3 for me to reduce by a factor of 3. For us to divide by 5, the numbers would have to end in 5 or 0, so in the ones place, this would have to be a 5 or a 0. And that's not the case. To see if they're divisible by 7, we just have to check. So let me try 104 first. 7 goes into 10 one time. 10 minus 7 is 3. I can't ask the question until I bring down the number. 7 goes into 34. Well, 7 times 5 is 35. That's too much, so I have to use 7 times 4, which is 28. I borrow from the 3 and make it a 2. and then add 10 to 4, which makes it 14. 14 minus 8 is 6. So I have a remainder, and there's nothing else to bring down. So if I have a remainder, then that means that it was not divisible by 7 without a remainder. So if you can't divide it by 7 without a remainder, then you can't divide 104 by 7. It's not divisible by it, is what I mean. So 7's out. For them to be divisible by 10, they would have to end in 0. So the only other thing we'd have to check would be the prime numbers. And I'm not going to take the time in this video to do that. I'm just going to say that you're going to have to trust me that this is as simple as it gets, because this video is now almost 6 minutes, so I'm going to have to end it here.